Hello, I'm Ben Usher, and this is my presentation on the 1980 eruption of Mount St. Helens. Beginning with a general overview, Mount St. Helens is a stratovolcano located in southwest Washington state. Um, this lies on top of the convergent boundary between the Juan de Fuca and North American plate, with the Juan de Fuca plate subducting beneath. Um, the subduction of this oceanic plate allows for magma formation in the mantle above it, as water that is included in the subducting plate infuses into the mantle above, lowering the melting temperature, allowing magma to form and melt through the crust and create volcanoes. With a general overview of the eruption, the initial signs began on March 16th, 1980. These were a series of small earthquakes in the regions, um, almost daily, and eventually leading up to a small eruption on March 27th. These events began to contribute to the weakening of the structure of the volcano, which was being greatly strained by the pressure of the magma beneath. Continued earthquakes weakened this further up through late April. This eventually was this eventually weakened the north flank of Mount St. Helens enough that it began to bulge at a rate of around 6 feet per day, and ended up totaling around a bulge of 450 feet. Um, in early May, small eruptions and earthquakes continued, and on May 18th, a major 5.1 magnitude earthquake triggered the full eruption. And analyzing the environmental impacts will go in roughly chronological order. After the 5.1 magnitude earthquake, the first thing that happened was the bulging north flank collapsed. This created a massive landslide, that is currently the largest landslide in recorded history. The material traveled around 14 miles down the North Fork Toutle River, and this moved massive amounts of sediments into the rivers and valleys. The most significant impact of this, however, was the continued weakening of the structure of the volcano, as this essentially opened the lid for highly pressurized magma to burst out, which it did. The magma bursted laterally through the structure of the volcano with such force that it created a shock wave that flattened all the forests in the 6 mile radius and continued blowing over trees and searing them within up to 20 miles. This removed even more material from the mountain, as well as pushed out magma and other volcanic material, which created lahars, which are essentially avalanches of volcanic material. These lahars traveled up to 300 miles per hour and eventually overtook the initial avalanche and from carried material further down the rivers and valleys. With this as well, there was a surge of water from melting snow and ice on the mountain, and this eventually led to severe flooding in the river, as can be seen in this figure to the right. As the hot ash, lava, and gases were expelled from the volcano, pyroclastic flows began flowing down slope. These flows were incredibly hot and decimated everything that they passed through. Even on satellite imagery today, the path of these flows can still be seen, as the regions are just completely decimated. Some of the ash expelled was also remained airborne. This ash cloud and plume created total darkness in regions up to 250 miles away. Further ash was carried almost up to 1,000 miles away and rained down across the country. As seen in this picture, there is the ash raining down totaled up to almost 5 inches in some areas. As you can see in this photo, the wheels of this truck are almost completely buried. While these impacts were already covered, it's good to really categorize them in the specific subsystems that they affected. The hydrosphere was significantly impacted as the riverbeds, lakes, and ponds in the region were overflowed with sediment from avalanches, lahars, and pyroclastic flows. Um, this greatly changed the landscape and altered the flow of rivers, created new ponds and lakes. Along with this, the properties of the water itself were greatly altered, including pH and temperature, as the material was so hot and the chemical compounds being released. The atmosphere was also greatly impacted as lots of particles and toxic gases were released into the atmosphere. Um, this ash remained airborne for many days and eventually was able to circle the entire globe after around 2 weeks. That being said, though, it did not cause as significant of a drop in global temperature as many other volcanic eruptions. The geosphere was also significantly impacted. The landscape, as mentioned before, was significantly altered. Almost 12% of the mass of Mount St. Helens was removed during the eruption. This spread a great deal of sediments across the region into valleys, and the magma and lava released also created new igneous rock. The biosphere was crushed in the immediate surrounding region, with most life in the rivers and forest immediately nearby being wiped out. These effects were mostly locally contained, and luckily, recent studies indicate that the biosphere is recovering with many diverse ecosystems returning. For humans, this was the most significant volcanic activity in the continental US ever. This resulted in 53 deaths from directly and 4 indirect deaths from related impacts, such as lack of visibility on highways. Lots of infrastructure was destroyed, including 47 bridges, many homes, miles of roads and railways, as well as infrastructure for the logging industry. This all totaled to a cost of about $1 billion. Travel and commerce was greatly limited in the region afterwards due to the destruction of rail, road, and issues with rivers, creating even more of an impact. This volcanic eruption did provide lots of important information for scientists. Because of its location and ease of access, this has become one of the most studied volcanic regions on the planet. Following these events, scientists have been able to better their monitoring and forecasting techniques and refine their tools utilized for this. More robust systems have been put in place to limit the impacts on humans for future eruptions. And more of the fun facts category. This event also created an incredibly unique landscape. Photos from before and after really show how significantly the region changed with Mount St. Helens peak dropping over 1,300 feet as a result, and so much of its mass being removed. And these are my references.